Consider this particular statement. We have character star a plus 5 is equal to inverted commas a b c d, and this is entire string and this is the closing brackets. Now you can see this entire program here. When I'm saying a plus 5, this is actually representing a statement like this: a of 5, it is equivalent to star of a plus 5. Now we need to identify how many tokens are present in this particular statement. Now for this particular statement, this character itself is one single token, this star is second token, this opening bracket is a third token, a is a fourth, this plus sign is the fifth token, 5 is the sixth token, this closing bracket is the seventh token, then we have single equal to sign, this is the eighth token, this entire string is one single token, therefore this is the ninth token, and this is semicolon is the 10th token. So in this statement there are 10 tokens which are present. Okay, now let us take the second example. If we have a statement like this: printf inverted commas I equal to percentage d, and this bracket is not there, I is equal to percentage d comma ampersand I is equal to percentage x. We have a statement like this, comma I comma ampersand I, assuming this is the statement we have. Now in this entire statement, this printf statement is one single token, this opening bracket is the second token, this entire string from here to here, even though we have multiple commas here, even though we have single equal to sign, but because this entire string is coming inside these brackets, therefore it is one single token, so this is considered as a third token. Then we have this statement, it is comma is the fourth token, this I is acting as the fifth token, this statement is the sixth token, this ampersand sign is the seventh token, this I is the eighth token, this one is the ninth token, and this one is the 10th token. So you can say in this entire program there are 10 tokens. Okay, now consider this question: which of the following strings can definitely be said to be a token without looking into the next input character? So which of the following string can definitely be said to be a token without looking the next input character. Okay, so for this we have the options, which is option number A is opening bracket, we have option number B is fun, we have option number C is not equal to sign, and we have option number D, which is this bracket. Okay, now see in this entire in this complete statement, now you can see this opening bracket. Without looking at the next statement, this can be said as a token. Clearly you can see it. Okay, now this fun is a name of an identifier, and this fun may be having some another character which may be associated with it, because we need to understand whether it is a function or whether it is a name of a variable. It can be anything. Okay, so we cannot say by looking at the next, without looking at the next symbol, what is it. It may be inside some inverted commas or something, so we cannot say by looking at it whether it is a token or not. But for this C, because this itself, this complete not equal to sign can be said as a token, and this cannot be said as a token just by looking at this. Why? Because it can be something like this, less than or equal to. This complete will be considered as one single token, right? So therefore just by looking at the symbol you cannot say it is a token or not. So here option number A and option number C, we can see without even looking at the next symbol, we can say whether these are token or not. Okay, now consider this one. We have to find number of tokens for the following expression. Find the number of tokens for the following expression. Expression is like this: a plus 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 b. Now in this entire statement you can see a is one single token, And when we have so many plus plus signs, then you have to identify what is the priority of these operations, right? For example, you have a postfix operation, you have a prefix operation, and you may be having an operation which is between two variables. Now here, because we have multiple plus plus signs, we have to identify which operation is having the maximum priority. Again, even if we have this one or this one, we can write a plus 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 plus. We can write it because it is saying that do increment the variable a 2 times. It means that first of all you are having priority to this one, and then you are having priority to this one. Okay, this is a perfectly valid statement. But if I am saying a plus plus b, now here there is a case of ambiguity. Why? Because this plus plus sign, these two plus plus sign, it can be a postfix expression, or there may be an ambiguity that how can you do this 2 times plus plus, right? So there's an ambiguity in this. But if we have a plus 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 b, now it is a perfectly valid expression because this can be acting as a one token. That means you are doing post increment on a and then you are adding it with the b. Okay, now in this entire expression you have to find the number of tokens. Now you can see this, you can consider this as one single token, you can consider this one as one single token because these are postfix expressions, and then you can consider this one as one single token and this b as one token. So how many tokens are there? This is token number 1, token number 2, token number 3, token number 4, and token number 5. Okay, so see, for this type of expression the parse tree is not possible, so it will give syntax error, but there is no problem with the tokenizer. Okay, so generally you can see this is how tokenizer is going to tokenize it, but the correct method should be something like this: a plus plus, this should be considered as one token, plus single plus, and then this should be considered the second token, and then we have b. Okay, so here in this entire case this should be a is a one token, this is the second token, this should be the third token, this should be the fourth token, this should be the fifth token, right? So this is, again I'm repeating here, for this type of expression parse tree is not possible. You can see for this type of expression parse tree is not possible. Parse tree is not possible, so it will give syntax error. So it will give syntax errors, but there's no problem with the tokenizer. Tokenizer is not going to find any problem with it. So the correct method generally is like this. In this entire expression, it should be, if we have a plus 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 b, it should be, this should be one side, this should be another side, and this should be like this. Okay, this is the correct method of doing this one. Don't worry, we'll see it. Okay, so now let us look at the next topic.